In this video, we will see how much energy consumption for heating increases when we change the orientation of the house from the south, where solar energy is maximum, to the north, where solar energy is minimum. We analyzed this heating energy consumption for different types of houses, for various usable areas, for different glazing coefficients between 15 and 30%, and for different climatic areas between latitude of 40 to 50 degrees north or south. These have been divided into 5 climatic areas according to the average annual air temperature. The effect of enlarging windows on the orientation of the house can be analyzed by the glazing coefficient, which varies between 15 to 30% and represents the ratio between windows area and usable area of house. By the distribution of windows on the four facades of the house, these are the percentage that approximately 50% of houses have this windows distribution. The sum of all four distribution is 100%. This is the distribution we will analyze in this video. Or by the orientation of the main facade. When we talk about the orientation of the house, we actually are talking about the orientation of the front facade passing through all cardinal points. I analyzed over 3,000 houses with the characteristics presented here. For a certain glazing coefficient, which is the ratio between the area of the windows and the usable area of the house, if the main front facade of the house has a southern exposure, the final energy for heating has a minimum value to the southern solar input. We will see how the coefficients of variation, which is the ratio between heating consumption with orientation over heating consumption for the south, which depends on climatic areas and does not depend on number of levels, roof type, usable area or the method for heat production and distribution. If you are an energy auditor or passionate about building energy, in the description below the video you can access a link to a video where I explain the calculations made for this video, a site with tutorials about building energy. The energy consumption for a heating depends on the heat losses to the outside and the solar gains. A decrease in solar gains through north orientation will result in an increase in energy consumptions for heating. The northwest, northeast, and north orientation have the same energy consumptions for heating. Now, if we increase the glazing coefficient, the solar gains also increase and the effect of changing the orientation of the house is amplified. We continue to increase the glazing coefficient. We always refer to energy consumption for the south for a certain glazing coefficient. We continue to increase the glazing coefficient. For a given climate area and orientation of the front facade, let's see what the effect increasing the windows area has on heating consumptions. For that, we will measure a heating consumption ratio depending on glazing, which is the ratio between heating consumptions at a glazing coefficient of 20, 25, or 30% over heating consumption at a glazing coefficient of 15%. Minimum glazing coefficient is 15% accepted by the visual comfort standard for a residential building. This ratio for heating consumption ratio depending on glazing do not depend on number of levels, roof type, usable area, or the method for heat production and distribution. For the southern orientation, we see how it varies depending on climatic areas and the glazing coefficient. We see how the effect of increasing the window surface, that is the glazing coefficient, decrease in colder climates areas where solar intensity also decreases. Now let's see what this report looks like for the southeast, southwest orientation. For west and east orientation, we see that the effect of increasing the area of windows also decrease with the orientation of the house because the solar intensity decreases toward the south. It is no longer depends on the climatic area or glazing. It continues to decrease to the northwest, northeast orientation, which have the same effect as the north orientation. As you can see, increasing the glazing coefficients in the east, west, northwest, northeast, and north orientation does not bring significant changes in heating consumption. By increasing the window area, we don't mean, for example, increasing the windows by 2 square meters only on the front facade, but rather increasing the window area simultaneously on all 4 facades by, for example, 2 square meters on the front facade, by approximately 1 square meters on the rear facade, and by 0.5 square meters on the two side facades, so that the distribution of windows on the all 4 facades is kept within the displayed coefficient. This coefficient represents the ratio between the windows area on a facade and the window area on all facades of the houses.